The Soviet Union, in the wake of World War II, embraced the atom's power with unwavering conviction. Nuclear energy, a beacon of scientific progress, promised a brighter future. It promised limitless energy to fuel their burgeoning industries and homes. It offered a powerful symbol of Soviet strength and ingenuity on the world stage. This drive for technological advancement, however, often overshadowed the potential risks. Safety measures were sometimes overlooked in the race for progress. The Chernobyl disaster, a stark reminder of the atom's devastating power, would forever alter the world's perception of nuclear energy. The Chernobyl nuclear power plant, located in Soviet Ukraine, was a testament to this ambition. The Soviet Union, experiencing rapid industrial growth, faced an increasing demand for energy. Chernobyl, with its RBMK 1000 reactors, represented a powerful solution. These reactors, a Soviet design, were lauded for their cost-effectiveness and efficiency. They could generate vast amounts of electricity, enough to power entire cities. This capability made them ideal for the Soviet Union's ambitious electrification plans. However, the RBMK 1000 design had known flaws, including instability at low power and a lack of a robust containment structure. Construction of the Chernobyl plant began in the 1970s. The first reactor went online in 1977, hailed as a triumph of Soviet engineering. 3 more reactors followed, solidifying Chernobyl's importance in the Soviet energy grid. Despite its initial success, the plant was plagued by construction shortcuts and operational errors. Safety protocols were often ignored. Warnings from engineers about design flaws went unheeded. This dangerous combination of factors set the stage for disaster. On April 26, 1986, during a routine safety test, a fatal chain of events unfolded at Chernobyl's reactor number 4. Human error, combined with design flaws in the reactor, led to a sudden and uncontrollable power surge. The reactor core overheated, causing a massive explosion that ripped through the reactor building. The explosion released a plume of radioactive material into the atmosphere. The plume, carried by wind currents, spread across parts of the Soviet Union and Europe. It contaminated vast areas with invisible, deadly radiation. Section 5. The immediate aftermath, evacuation and uncertainty. The immediate aftermath of the explosion was chaotic. The extent of the disaster was initially downplayed by Soviet authorities. The nearby city of Pripyat, home to many plant workers and their families, was not evacuated until 36 hours after the explosion. Thousands of people were exposed to dangerous levels of radiation. Firefighters and liquidators, workers tasked with containing the disaster, heroically risked their lives to extinguish the fire and entomb the reactor in a concrete sarcophagus. Section 6. The invisible enemy, radiation's silent spread. The invisible enemy of radiation spread far and wide, leaving a trail of fear and uncertainty. The true extent of the contamination was slow to emerge. Governments struggled to respond to this unprecedented disaster. The Chernobyl disaster forced the world to confront the terrifying consequences of nuclear accidents. It shattered the illusion of absolute control over the atom's power. Section 7. Chernobyl's legacy, environmental and health consequences. The Chernobyl disaster continues to cast a long shadow over the region. The area surrounding the plant remains an exclusion zone, largely uninhabitable due to radiation. The long-term health effects of the disaster are still being studied. Thousands of people have suffered from various cancers and other health problems linked to radiation exposure. The psychological and social impacts on survivors and their families are immeasurable. The disaster serves as a stark reminder of the enduring legacy of nuclear accidents. Section 8. The future of energy, balancing progress and risk. The Chernobyl disaster prompted a global reassessment of nuclear power. Safety regulations were strengthened and reactor designs were improved. However, the debate over the viability of nuclear energy continues. Proponents argue that nuclear power, with its low carbon emissions, is crucial in combating climate change. Opponents point to the risks of accidents and the challenges of nuclear waste disposal. Section 9. Conclusion: remembering Chernobyl, shaping tomorrow. 30 years after the disaster, Chernobyl stands as a monument to human ambition and its potential for catastrophic consequences. It is a stark reminder of the importance of vigilance, transparency, and responsible stewardship of technology. As we face the challenges of the 21st century, including climate change and growing energy demands, the lessons of Chernobyl are more relevant than ever. The future of energy requires careful consideration of both the benefits and risks of all available options. We must strive to harness the atom's power safely and responsibly, learning from the mistakes of the past to ensure a brighter and safer future.